hey, hi there. In this video, we are going to watch the Falcon Heavy, one of the most powerful rockets ever built. We're going to watch its test launch, and then we're going to use the altitude data for the booster rockets as an example of graphing position over time. So just quickly before I start the video, the Falcon Heavy is this rocket up here in this nose part called the fairing. That's where the payload sits. That's where the stuff they're trying to get into space is. And then pretty much the entire rest of it is just dedicated to getting this thing off the ground and into space. You have two side boosters, plus this one main booster in the middle that that send all the thrust, that produce all the thrust needed to get this thing off and get it into space. So what we're going to do is we're going to watch it lift off, and then we're going to watch the point where these boosters separate, and then I will skip ahead a little bit, and we'll watch these boosters come down. It's one of the coolest things about this rocket is that the boosters actually land back down, straight up and down. So we're going to start about 15 seconds before liftoff. It's pretty exciting. And then we'll watch till the boosters separate, and then skip ahead to where they come back down. Then I will show you the data.
Minus 15, stand by for total count. 9,
8, 7, 6, 5, 4, 3, 2, 1. Well, there it goes. It's got some serious thrust. Lifting off from Cape Canaveral, Florida. Notice it's recording the altitude as well as the speed over here. So we can see it's already almost 2 kilometers off the ground. It's going almost 600 kilometers an hour. There's some excited people out there. Okay, it's already over 8 kilometers up from the ground. Moving extremely fast.
You heard the call out. Vehicle is supersonic.
It's now supersonic. It's going faster than the speed of sound. And now we get to see this view, these camera views.
Side boosters are now throttling back up to full power.
So you can see these are where the side boosters are attached. There's one of each.
Next up, we'll be waiting for the side boosters to begin to throttle down prior to booster engine cutoff and separation. 2.5 minutes into flight.
So another 50 seconds, and then the boosters will separate.
Looks good on the Falcon Heavy.
Check this out. This is a map of the launch. You can see the curve that it's supposed to take as this craft goes up in the air.
The F1D engine performance is nominal. Side boosters have begun to throttle down in preparation for the upcoming shutdown in 20 seconds.
So you can see the black of space already. So they're pretty much outside of the main part of Earth's atmosphere, 50 kilometers up in the air.
Major event coming next. Side booster shutdown and separation.
Okay, there go the side boosters. They're headed back to Earth. They're running up into space. Okay, and I'm going to pause the video. Boy, that was really loud. It was about 62 kilometers when the side boosters left. That was what we want to keep an eye on. Now we're going to skip ahead to about where the side boosters start coming back down to Earth. This is one of the innovations of SpaceX. They can return their boosters and save a whole lot of money by doing that. skip ahead a little farther. And let's see how they're doing. That's Florida down there. So this data is now for the main rocket. We're going to ignore that. We want to watch these things land. See their landing sites. Check this part out. There they come. Perfectly synchronized. Landing, standing back up. And that's a little more than 8 minutes later. Okay, so that was loud and exciting. We see that after 8 minutes, these rocket boosters are back on the ground. So cool. I thought that was cool. I am going to show you the data, roughly the data, for the altitude of these booster rockets as they went up and down. So what we want to think about here is we want to think about how far away the boosters are from the ground. The ground, we would say, is position 0. Right? That's position 0, or altitude of 0. And over time, they're basically going up and down. So here's some data for that. At time 0, the altitude was 0, and at time 8, right, 8 minutes in, it was also at 0. That's when they came back down. And so they changed altitude over here. And you can see it was right around 2.5 minutes was when they reached their maximum altitude and separated, and that was their altitude of about 62 kilometers off of the ground. So we have time, and we have some kind of position data here. Let's take it all and make a graph. Okay, so I clicked and dragged to highlight. I go over to my graph button and click on it, and boom, there is altitude versus time. And check it out. The X and Y axes are already correctly labeled. It says time in minutes. It says altitude in kilometers. We change the graph title just so that it's something more interesting or relevant, describes what's going on. Falcon Heavy Booster altitude data from test launch. This is the test launch. Okay, and so we want to look at what exactly we are seeing in this graph. So we're seeing it start at position 0 and time 0. At position 0 and time 0. I can actually make another little fun change so that we can see things a little bit better. I can add some dots. Well, let's make them bigger. There we go. So these are all these points are the individual sets of coordinates from the data right here. So now we can just see them individually. So at time 0, the altitude was 0, and you can see it starts climbing slowly and slowly, and then it really starts to get away, far enough away from the Earth's gravitational pull that it can speed up. And then this was the maximum altitude, right? That's where the boosters separated, and they started coming down. And you might have noticed that what happened at the end was, the boosters are basically falling straight back down to Earth. But then when you get to the end, when they get really close to Earth, they fire their rockets straight down. That's called retro boosting. Retro meaning sort of backwards or against. So what they're trying to do is use the rocket propulsion to slow themselves down, and they did that. And so they start approaching the ground very slowly at the end, and they come down here. So we can see this is a graph of the position at every time during that test launch. So at time 2 minutes, the position was about 23 kilometers above the ground. At time, this time is 5 minutes. The altitude was 13 kilometers above the ground. And so you can see there's no negative position in this because we said up is positive, and the rockets never go below. They never go down from their starting point. But we can see what's happening here. We can see as time passes, altitude goes up, but then it goes back down. This is not the same thing as the total distance traveled. If we had total distance traveled, it would just be going up and up and up. But in this case, we're talking in position, and we're seeing position as it's moving away, and then moving back towards where it started as time goes on. So moving away, moving back towards. And shortly, we're going to start looking at what it means to consider how steep this scratch.